So here's another example. We are going to determine the function that has the following graph. And here is our graph. I didn't actually mark the y-scale, so let's go ahead and do that now. That'll be 1, 2, and 3. So, in order, first let's go for the midline. Midline is supposed to be halfway between a maximum and a minimum. Halfway between a maximum and a minimum will be maximum plus minimum divided by 2, the average of the maximum and minimum. I see that the maximum y value is at 3. The minimum y value is at 1. And taking the average of those, we get 2. So the midline is going to be y equals 2. You'll also notice that there are several points that are on the midline as well, halfway between the maxima and minima. Next up, the amplitude. The amplitude is going to be the distance from the midline, which I now feel comfortable drawing in here, y equals 2. Distance from the midline to a maximum, or the midline to a minimum. So midline to maximum would be 3 minus 2, or midline to minimum would be 2 minus 1. And in either case, we're getting an amplitude of 1, which lets us know that the absolute value of a is equal to 1, which lets us know that a will be either positive or negative 1. We'll determine which one in just a moment. For the period, period is the horizontal distance from a maximum to a maximum, or from a minimum to a minimum. I'm going to recommend that you go with maximum to maximum on this one because the function starts with a maximum, meaning that x equals 0 can be our start. The end of our period will be 4. Lets us know that the period is going to be 4 minus 0, or simply 4. If you did want to go minimum to minimum, the period starts at 2 and ends at 6. That would be 6 minus 2, which again would be 4. Borrowing a formula, we know that omega is supposed to be equal to 2 pi divided by the period. So that would be 2 pi divided by 4. Reducing this fraction, we'll get that omega is equal to pi over 2. And I guess technically this is part 4 and 5. But determine the mother function, as well as whether a is positive or negative, is determined by what's going on at x equals 0. At x equals 0, I would describe this point using, we are at a local maximum. Now if you happen to start at a local maximum or minimum, you are dealing with the cosine function. Y equals the cosine of x. The fact that it's a maximum indicates that that is a typical cosine curve. That is to say, no reflection has occurred. Now, given that no reflection has occurred, we'll want to see a positive value for a. So overall, our function should take the form y is equal to a times the cosine of omega x plus b. Now we calculated a to be either positive or negative 1. We want the positive version of that. Instead of saying 1 times the cosine, I'm simply going to say cosine. Omega x will be pi over 2 times x. And our value for b comes from the midline, that is y equals 2. Final answer for this one, y is equal to the cosine of pi over 2 times x plus 2.